a quick recap that we have done in the previous class. Like we talked about the functions of management, and in the first, the portion of the functions of management is the planning part. So we talked about construction planning, and we have taken this layout, and then we have also, discussed about the three-dimensional view of it, and in terms of architectural and structural, and also in terms of MEP, mechanical, electrical, and plumbing. And then we talked about the work breakdown structure. We have fragmentized the different activities based on the logic or in the order or in the manner in which it is constructed, right? And then we talked about the duration to it. That is the second functions of management. This is scheduling part, right? We talked about different rates in construction, and this is what we left in the previous class. It's the construction scheduling, right? So in this lecture, we'll be focusing primarily on how we make use of these details to, actually effectuate the construction process, right? In a layman sense, it is just like how we achieve, the plan is just how we achieve it. And the sequencing is like when we do that particular activity to accomplish the entire project within the stipulated deadline. So that's the basic layman's definition. But more than that, like scheduling is not only giving a time frame to a planning or abstract plan, but also it gives you a sequence, like when at what point of time it should be, started, and what point of time an activity should be ended. So that's basically the clear definition of what is scheduling. It is not only giving a time frame, but also have a definite start and end period. So this is pretty much an event, like we consider each activities or like an event, right? So each activity is an event by itself, right? So it has a definite start and end time. And the overall project itself is kind of an activity. It also have got its different start and end. So we can define, in whatever means you like, but this is the basic understanding, right? So in this lecture, I'll be focusing on how do we actually give time frame to a plan and so as to sequence in a logical meaning to effectuate the construction process and also to accomplish that within the deadline or something like that, right? So this is what we have done in the previous class. We talked about the different work breakdown structure and its duration, right? And then we talked about one thing which is pretty important to discuss again, that is like the overall project duration. So if you talk about when I add all the durations of all the activities, it comes under 149 days, which is something around 5 months, approximately 5 months. So it is not the actual project duration. Remember, project duration is a little different from the the overall addition of durations, right? So we are not going to achieve this in 5 months' time. We may achieve it early or we may achieve it late, depending upon the sequencing of this particular activities, the overall activities, right? Right. So I just draw a quickly a bar graph. This horizontal bar graph, you can call it like um, this is I take January 2020 as the reference time or reference month, right? So I just put different activities. A00 is the site clearance, and 01 is this surveying, and 02 is marking, and 03 is earthwork. So all these things have a 1 day duration. So this is a day in a month. So this is January. Want of space, I've just restricted only to 25. And also from the schedule, I understand that major time is for this thing, RCC slab and beam. So I just estimated to 25. Right. So the activity ID. So I repeat, 00 site clearance, 01 is surveying, 02 is site marking, 03 is earthwork excavation. There is 1 day, each is 1 day. And then 04A is dewatering optional, 04B soiling optional. So both things are optional, right? So we generally do not have two of these events occurring simultaneously. Say if dewater occurs, we don't have to really soil it. Like we have to do it, but I know not at that point of time. Fetching out the water is very important, or draining the trench. Dig trench with the saturation and maintain the the water level or something like that. So that's a prime importance. Then you can go for soiling or something like that. Or if de-water does not happen, like water table does not increases or water does not percolates into the pit, then you don't have to really go for dewatering, but you can look into the soiling. But soiling also is optional. It only depends on the safe bearing capacity of the soil. Say if it is 18 ton per meter square, the safe bearing capacity or something like that, it's fine. But if it is less than that and the soils are pretty loose in some places in our country, then you have to really look into the soiling, incorporating micropiles and something like that. So that's an optional thing, right? So that's why I just put AB instead of 04 and 05, right? And 04 itself is an optional activity, right? So it may occur or may not occur. So if it is occurring, if you think that that will occur, you give it in a schedule. That's a ideal choice, rather than you think of it like after you give it to the client or something like that, right? Then 05 is transporting excavated earth material in excess or something like that. And PCC laying for footing is 2 days and something like that, right? This is typically a very important, right? But if you take a look at this Gantt chart, it's not a Gantt chart, the bar graph. This bar graph does not give us anything. It can only give us like which is the activity that consumes longer duration. It is A12, which is the reinforcement. I think it's beam and slab, right? So both consumes the longest duration, which is 20 days from the start of initializing it and till the stripping and curing of that particular element, right? So that's the. But this does not yield any comprehensive results. I'll just put in a full screen mode. Right. So this bar graph does not fetch kind of any significant thing other than the longest durations or something like that. But later, a famous person, a mathematician called Henry L. Gantt, has developed a chart which is known as Gantt chart, which is still in use. 1900s technique, right? So that's still in use even centuries later. And the advantage of that particular method is it will sequence it based on the occurrence. Right? So this is just a bar graph. What Henry L. Gantt has done is he has sequenced based on the occurrence. Like we know that this is A00 site clearance. Unless we don't clear the site, we cannot start the other activities like site surveying or site marking or even excavation, right? So he has made that into a sequence, right? I knew that. So before we get into that, we need to know the logical sequence or the sequence that the activity is occurred, or the sequence that activity has to wait so as to effectively proceed or something like that. So let's take a look at that. This is the first activity. It's called initial activity called site clearance, and the predecessor or activity before that. Of course, the land acquisition, the documentation and all were there, but that is not a part of a construction. So this is something related to a construction. So our schedule is based on the construction of the single story residential building, right? So in that case, this is the initial activity. Once everything is ready, the company starts, constructing, starts the construction process, and this is the first step. So site clearing the site, excess vegetation or something like that, and something like that. So don't ask me like whether they have a permission from environmental agency or something, but all, assuming that all are there, so it's ready to go. So that point, the first initial stage is the site clearance, right? So that's why it does not have any predecessor. Predecessor activity that is prior to that, right? So unless you don't finish that, don't have permission to start this. So that's the basic logic. Then surveying. When site is not cleared, how do you perform the engineering surveying? You measure the land or something like that, or finding out the, topography or something like that, like landscape mapping and all, right? All those things can be done only if you clear the site, right? So that's why it is followed after A00, right? So the predecessor of surveying is A00. Once you do without doing a surveying, you cannot do a site marking. So how do you really do without? You cannot haphazardly map the elements in the ground, something like that. So you should have a scientific principle and scientific document to measure, not only measure, to also to provide, uh, good measures to construct or something, like good measure to even excavate, right? Something like that, right? So then it is site marking. So you can see site marking depends on surveying. After surveying, it gets site marked, but surveying itself is after site clearance. So that's why it is A00, A01. So that is why it is called predecessors. But we generally look into immediate predecessor. What is immediate to that, right? Say, for example, if you travel from your place to VIT, if somebody asks you just like, tell me how you reach VIT, you just say, I landed in airport, then I reached VIT. You don't say you've taken a share auto or taken a taxi from your house to the airport of your destination, I mean, of your place, and then the destination is Chennai. And you don't say everything, right? So it's understood. I landed in Chennai and I reached VIT, something like that. So it's immediate predecessor. Then sometimes they'll ask like shortest route, in cabs. Generally, the drivers look into the shortest route. They don't do that in the initial stage itself. They only find, as they go, what are the different shortest possible routes, and also they look into the feasibility of the route. Sometimes some short routes may not be very ideal for four-wheelers, something like that, right? All those decisions are taken at that moment, like at that point, and look into the immediate predecessors of that, right? So that's basically the predecessors, like what comes immediately to that, like that's the immediate predecessor, right? Then you can even take a look at it goes on and on. It starts from A0001, then 02 and 03. Here this dot represents all these things are prior. Right? In this case, you see the final A05, the predecessor are almost everything from A00 to A04B, right? Even though it's optional, so that's why I just demarcated with asterisk. Even though it's optional, it is to be considered or something like that. What happens suddenly if a water table rises and you need to perform this dewatering? So transportation can be, not immediately after the earthwork excavation, but can delay it. Say sometimes in soiling requires some portion of the excavated earth. So to tamping the loose soil, they might require an extra soil and boulders that they have done during excavation, right? So that's why transportation can be waited a little bit later. Excess, here we say excesses like after soiling, what is the excess earth or something like that. So this is typically the way in which it is done. And sometimes you don't have to really wait this portion. Like once the earthwork is done, excavation done, like so once this thing is done, like A03, if dewatering and soiling does not occurs, you can directly go for PCC laying. You don't have to really wait for after transportation of excess earth. You can lay the PCC footing. So we can even directly jump through A03. After earthwork excavation, you lay the PCC footing, right? So PCC, stuff for creating the hard stratum for foundation, right? Something like that. So that's how it is just sequenced. So in a previous case, we don't have any of those sorts, and it's still a bar chart, right? So once you incorporate all this necessary, predecessors, and it is called a Gantt chart. Right? So let me take a look at that. So I just keep this empty so as to, um, not discuss that now. Probably you can do it whenever you're free, and then we'll discuss in the next week, right? So next class, and not next class, next week, Monday, I'll just upload this document today in Drive and I'll share it to you. So download it and just try to find out the predecessors, possible predecessors or something like that, right? This is the Gantt chart, right? Right. So Gantt, you note on the spelling, it is Gantt. Generally, people forget double D. They just provide single T, but it's a name after the person who developed this chart called Henry L. Gantt. Right. And A00, as I told you, A00 is the site clearance. and A01 is the surveying. You cannot do surveying before clearing the site. So that will give anonymous result. This may not be as comprehensive. So that's why generally people do site clearance first, then they look into the other aspects like surveying. A01 is surveying. A02 is the site marking, right? So once the surveying is done, that report, based on the report, you will just mark the site for excavation. Like, so you generally, I told you, in quantity surveying, you'll be learning a concept called center line, or even in building information modeling, if you practice generating BIM models in Revit, the first thing is you will be marking the grid lines, which is as simple as the earthwork excavation. And sometimes when you draw a wall, it will ask three different lines, like center line, or interior lines, or exterior lines of the wall, or something like that. So that's the advantage of building information model versus the conventional solid model or a CAD model, something like that. So all those things are just like site marking. Then A03 is the earthwork excavation. Say it takes 1 day's time. And 04 is an optional. It could be either dewatering or soiling or sometimes both. So if you consider both, then you have to move a cell. It will be 2 days, no 1 plus 1, 2 days. So I'll just assume that one of the two happens, like either dewatering or the what is that soiling happens, right? Something like that. And 05 is the transportation of the excavated earth, and 0C is PCC laying. Remember here I've just made the PCC laying and transportation happens on the same day. So it's a parallel activity. Remember, all these things are called finish to start. Unless A00 is completed, A01 cannot start. Right? And same way, A2 and A02 and A03 and A03 and 04 and 04 and 05. And if you take a look at A05 and 06, which are parallel activity, those are all start to start. Both can be start at same point of time, right? This starts and this also starts, something like that, right? And the next thing is, like, you can even model this as this another variation of it. It's not entirely different, but in the previous case, A05 and A06 just like start to start, right? But in this case, we know this is an optional. A04 is either dewatering or soiling. It's an optional. So once the excavated earth is done, and we are not pretty sure this happens, right? So A04 does not, we assume that does not happen based on our experience and also from the, weather report or something like that, or from the scientific document from government agency. The stratum is hard, as well as it does not have water table percolating into the pit, something like that. In that case, after the excavation itself, you can really, start the PCC laying. But a caution is that once you create, create an entity called A04 as optional, what happens if suddenly it happens? Like, how do you generally put that in the activity or the work bedding structure based on someone's input or some government agency's report or something like that? So dewatering can have is required since the water table can go up, or the strata of that particular location might be very poor, even though the particular geographical location is very good, having good strata, right? So optional is optional, but it will create some thing in our mind. So even though we plan to start the PCC laying 1 day, but if suddenly this happens, this also should not get delayed. So that's why we give 3 days instead of 2 days. So 1 day is a buffer. If this happens, that particular day will be allocated for this. If this does not happen, then we will complete it once you finish this transportation thing itself, right? So that's the power of a good schedule or scheduling people or planning or personal or something like that, right? So that's how they generally do this, right? But increasing a day is not a solution. Here it is not an increase of a day. If this happens, then this activity starts from here, even though this will consider as a buffer. If this does not occurs, we will finish it by the end of this particular day, 6th day, right? So this will be void. It can't be like this. Take this and this. The center cannot be void. It is not like that, right? So, something like that. So it should be first. It can compromise, or it can be compromised at the end. So as simple as that. So this is how people generally schedule a particular construction. Since it's a simple activity, we could able to do with Excel or something, but having a huge complexity or a project which has a multifarious activities, then you need to look into the computerized solution. You can either use Microsoft Project or Oracle Primavera, which is at present considered to be the too powerful thing. And there are other softwares like Power Project, and other elements are there, but you need to really accelerate your learning or something like that. But these two are pretty much common. It is used in most of the in construction companies till now, and both these are user friendly, so you don't have to really look into much things, right? And end of this today's lecture, I'll share some of the videos that we captured. We have conducted a lot of workshops on these tools. If you're really interested, you can take a look at that. Otherwise, you can pretty much ignore that. Right. So this is how you generally do the scheduling portion. Right. So, and so far we talked about a very generic way in which you can schedule a particular construction activity. But let's take a look at how it is done professionally or in a realistic fashion. Right. Right. So far we talked about construction scheduling with the predecessors, and let me go to so with the duration like this. So we have taken the duration, then we considered the predecessors, then we created a good logic. Here it is, good logic in which it is done. Next step is pretty important. It's called calendar days. Like so far we've discussed like day is 1 day, 2 day, right? So if for a particular activity, say it happens on January 2nd. So A00 starts on 2nd January and A01 starts on 3rd January. So this is January 2020. So that's how it is done. Let me explain you with an example. Full screen. Right. So I'll just zoom much closer. Right. So this is how it is done. So in the first thing, like first and foremost important thing in a scheduling is setting up a calendar. So calendar here, what I refer is the number of working days per week, and also you need to mark the holidays. So you should exclude the holidays, or sometimes in some countries they have a differential work week also. Like for example, they work from Saturday to Thursday. They have a Friday, Sunday to Thursday. They might have a Friday and Saturday holiday, something like that. But in most of the countries, they have Saturday and Sunday off. But sometimes most of the construction company does not allow for 5 day working, but they only look into 6 days working. So the contract term itself is very stringent, so they can afford to have a 5 day work week. So they have a 6 day work week generally. So in this particular example, say Monday to Friday, it's a standard calendar, and I just say 8 hours per day, excluding lunch and refreshment times and something like that. So January 1, 2020 is a holiday, which is considered to be New Year Day. So very important is you need to list down the holidays. Say in our country, 26th January, the Republic Day, is a holiday. So 26th January of 2020 falls on Sunday, so we don't have to really look into that. But some regional functions like 14th Pongal and 18th is Thaipusam, but here it comes under Saturday, so we don't have to really do. Or sometimes the company specific, work day. Say this example, I just take 9 as random day. Say it's the founder of the company might have born. So the company policy is the 9th January is always a holiday, right? So you need to really look at that. Or say you take international project and the 9th January of that particular country have got a holiday, which is something like their prime minister was born or something like that, or then their freedom fighters were born. So something like that. So that day is considered to be off day. So you have to really mark that. So before you do a schedule, you should take a look at all these factors. It's not like only uh, stringent time. It's not like it is not like as how you schedule, right? So that should be taken care of, right? So that's pretty important thing. So let me go to this thing. Say activity A00 is the site clearance. So first Jan is off, so I have to start my work from 2nd Jan. So start day and end day are the same. But since it's a 1 day, so start day and end day are the same. So predecessor is not there. But for this thing A01, the predecessor is A00. So since I just didn't want to have this in this space, but actually A01 depends on A00. It's not independent. It's 1 day, so it falls on 3rd January 2020. And this is Thursday and this is Friday. And remember, we have only worked from Monday to Friday. So Saturday and Sunday is off. So this is next Monday. 4 is Saturday, 5 is Sunday, and 6 is Monday. Right? So A02 starts, it's 1 day, and it starts on Monday rather than Saturday. Right? So remember, it is Monday to Friday work week. And A03 is, the excavation that happens the next day, the 7th day, something like that. But if you take a look at 6 days per week, if you take a look at 6 days per week, say this 00 is this is Thursday, Friday, and since Saturday is working, so A02, which is the site marking, which is on 04, which is the Saturday. Then Sunday is off, then we come back to this particular activity as Monday, right? So, but overall duration remains the same, but the calendar dates vary. So this is a very important professional scheduling, right? So this completes the scheduling, and your DA1 will be based on the scheduling. So I'll explain your DA1 tomorrow. The deadline for your DA1 is 31st January. You have a lot of time to do, and we'll be doing planning and scheduling for a particular construction that I will discuss in tomorrow's class. Fine. Right. So this completes today's lecture.